Alrighty, there we go. Up and running. Whew, man, busy Saturday. But a couple of weeks ago, I said I was going to remake Witch of Endor, and I intend on actually coming through on that promise. So let's put in a couple of hours today. I have tried going through the pages. Well, actually, we did it together. We went through the texture pages that I've downloaded from the only surviving remnants of the game. Let's see, where is it? I did attempt to organize, sort out all of the assets, like player sprites and animations. Some of the run cycles look goofy as heck. I don't think I quite got them correct, but you know, we got graphical components. We did sort out the buffering with the tiles. That was fun. Since I wanted to match the visual aesthetic, I suppose that was kind of required. And yeah, we'll see if we can recreate it. Cool. So first things first. So we got our tiles. We have our base tile. We have our variation tile, and we have the, I think this is a puddle tile. So let's start by exporting this. Engine tiles. PNG. Tiles PNG. Alright. Get the tile map layer. Make a new tile set. How big are these things? 16, so 32 pixels. Okay. So tile map layer, set up the dimensions, 32 by 32. We went really low here. Set up the tiles. Okay, now we do have two terrains. So we're going to add a terrain set. We're only going to be matching corners. And then first element is dirt light. And the second one is puddle. Okay, we're going to pick some contrasting colors because we're going to have to use these colors to paint the terrain data. Let's go to paint terrains, terrain set 0, dirt light. Okay, so we're going to choose all of the tiles that participate in the dirt light, and then we're going to choose all of the corners that make up this terrain. I think this should work. Same thing for the puddle. And that's it. Okay, so we have our terrains. Actually, we need to first of all paint with the base tile. Next, we would do... I don't think there's a way to completely clear the whole layer of all the paint data. Yeah. Okay. Save it up. Save as. Tile sets. Okay, so this is going to be valley. And we're going to need to get ourselves another tile map layer. We're going to load valley tile set so that we could paint with the terrain, just like that. Nice. Okay. It seems like it doesn't quite line up on a couple of tiles here. but we'll work with it. Okay, and then puddle. So this is dirt light, dirt base, tile map layer, load up the same tile set, and then this is going to be puddle. There we go. Nice. I do find it a bit annoying that when you paint or when you erase some tiles, it doesn't actually fix the nearby tiles. That seems like a flaw. Okay, nice. It's looking pretty good. Cool. Next, we need to get our player object. So we're just gonna, looks like we already created the scene for him. We do not have anything else done for it. So let's load up players. Okay, what did we do here? Okay, we have some semblance of a run animation by the looks of it. Oh, this looks terrible. So we don't have too much here. We just have a run and we have an idle frame. That's it. Which, you know what? Let's say for the time being this is okay. We can always come back and fix it up. I'm going to render animations. Engine. Sprites. Player. And then character 1. Cool. Oh, don't flatten. Also, don't export a single frame. Is this a new game project? This is a game project that I made in GameMaker Studio several years ago, and I lost the project and I can't make any more updates to it. So I figured I'll just rebuild it from scratch. And this time I'll rebuild it in Godot. So in short, yes. In long, no. Sort of. Maybe. It's a short one. I like the aesthetic of the project, so that's why I didn't want to just discard it and write it off. Okay, can we... what's happening here? Yes. Render animation. Excited. So am I. This should be a fairly short project to put together. I mean, technically, if I had the whole weekend available with no commitments, I probably could knock it out in just one weekend. Oh, come on. Oh, I called character 3 and name character 2. That's not good. It's just character 4. Okay, now let me just do this one again. Mm-hmm. Okay, there's an empty frame in each one of these, but that acts as a separator. I am going to make a new sprite frames. We're gonna have run, and we're gonna have an animation called idle. Okay, so let's do idle, nice, and then run. It's gonna be this. At some point the legs disappear. I'm not entirely sure what's happening there, but sure. Again, we'll probably have to redo some of these animations because I couldn't for the life of me recreate nearest. There we go. Couldn't for the life of me recreate the frame order in the same way that it was made before because they weren't really put onto the texture page in the same order. Okay. So we're looking something like this. Love the character. Thank you. It's one of the four characters they're supposed to be. So I'm gonna save this. This is gonna be. This is sprite frames. Okay, so this is char. What is it? 3? Yes, char 3. Okay, so we're gonna make unique, and then instead of these frames, we're gonna do the next one. So that's the run. Ah, there we go. So save as char 4. This is supposed to be a co-op game. The first one had local co-op, so it's just same screen, you know, friends getting together, or I suppose you could play it with a Steam's play together. What did I just name it? Right, this is character 2. Mm-hmm. Okay. We'll save as character 1. Cool. Okay. So now that we have this set up, should we give the players the ability to choose which character they're playing as, or is that not something that's important? Multiplayer split screen. It was actually same screen because the players never really traveled too far away from each other. The camera just kind of zoomed out and let the players do their thing. Okay, let's try this. Script. Player GD. Oh, geez. Okay. Do we want this? Possibly. Direction UI left and right. What the heck? No, go away. We don't want template script. Here's what we are gonna do. We know that the players, if we give the players the ability to choose what character they play as, then we need to... Wait a minute. There's an intro cinematic which takes place between two specific characters, which is character 1 and 2. So, technically, if you play as if you play by yourself, you'd get the first character. If you play together, 2 people, it's the first 2 characters. The third and the fourth are just kind of fillers. That's fine. You know what? We're not really. We don't have to root this in logic. Not in this particular case. Okay, why don't we get another script? This is going to be a global script. So it's going to be master node. There we go. Steven, welcome back. Let's get globals. We're going to load this master node as a singleton so we can talk to it. And it's actually going to be the master node that will contain the character choices. Okay, so let's do var character choices. When the characters choose, right, you won't be able to choose the same character twice. So when in the main menu, the characters would choose which skin they're going to play as, and it's going to be populated here. Okay, got it. So in the player, we can load the sprite frames there, but since the main menu is where we select which character we'll be playing as, the player will have to fetch that information. So let's do temporarily. Should we give them names, or should we just do character 1, 2, 3, 4? I suppose we could just do 1, 2, 3, 4 because that's how they're listed here. Okay, so let's do I guess 0, 1, 2, and 3. So these are the character selections. Nice. Now here, I guess let's just load the skins first. So they will be loaded in the same order they are listed. We're going to load them up like this. That is not what I wanted to do. Okay, can we do that without variables? Oh man, really? Oh, son of a gun. We've seen this before. They changed it. Oh, for God's sakes. I could just preload the entire stack with drag and dropping it, but now I have to do this nonsense. Alright. Fair enough. So skins, this is where we load all 4 of them. It's okay to load everything because this is a small game. Then we're going to do a ready function. In the ready function, we're going to take a look at which skin we're supposed to use. Now, we need to sort out which character is which. Okay, so my player number set to 0 in the ready function. My player number is going to be get tree. We're going to talk to the whole tree. Get nodes in group called player group. Now that group doesn't exist. We need to make the players be a part of that group. So if there's multiple players, they can all basically see each other. Oh, that's new as well. There we go. So that's going to be part of the player group. And then within that group, we're going to find self. Hey, Zoltan, welcome back. So that tells us what number we are, which is in turn going to allow us to... We don't want to use this number directly here. We actually want to correlate what skin number has been chosen in the main menu, which we haven't done that part yet. So we'll have to do this. We talk to the animation player node, sprite frames. We're going to talk to the master node, which has the character choices variable, and then we're going to use the number of the player to figure out, okay, I'm player 0, what skin was chosen? Oh, it was 0. I'm player 1, what skin was chosen? Oh, it was 1. Well, these could be in different orders. This could be 3, 2, 0, 1, for example, in which case the first player has chosen the third skin, second player second skin, etc., etc. Okay, now that should, hypothetically, already yield something. Let me run this. Oh yeah, we haven't run this even once before. So in that case, let's place player right here. Set the currency as the main one. And we crash. Invalid assignment property key sprite frames with the value of type integer. Right. Okay. This is master node. That's this guy. Character choices. That's this guy. Then we use our player number to access one of these numbers, and then that number has to be used to get the skin. Right. We're just one step short. There we go. Hey, look at that. And then none of them are the same. Perfect. Okay, that's cool. We're gonna need to do something resembling a camera. Okay, so let's get character body. This is going to be camera carriage. We're going to put a camera 2D node into it. Nice and center. Let's save this as a scene. Actually, should save it before I move it. Save branch as scene. Objects, camera, carriage. Nice. Place this here. And then I can edit it. Set the camera zoom to, I guess, what do we want? Half? Oh, no. Yeah. Nice, okay. That's looking good. Perfect. What's next? The camera carriage has to position itself between all of the players. Maybe we should get the player to start moving first before we can focus on that. Okay. So. Are we going to do this through actions, or are we going to do this through just pulling the keys directly? 4 players, 4 controllers. I mean, actions make it easier. Move left, move right, move up, move down. Okay. I think this is arguably the longer way to do this. Okay. Yep, and then keyboard. Okay, so left, down, up, whoops, right. Nice. Okay, now for the controller, I have one controller connected, so that's going to be here. Okay, left, right, up, down. But that's all devices. There should be device 0. Yes. Cool. Okay, same thing here. Left, device 1. Right. Up. Oh. Down. I think if we had any more players, I probably would have just done coded controller detection. Okay, what is this? This right? Right. Okay. Left. Right. Up. Down. This is device 3. 3. 3. 3. Okay, that looks about right, except for this. What is this? Controller 4. That should be 3. 3, 3, 3, 3. Nope. That seems wrong. That should be 2. That's part of the reason why this is such a pain in the ass. I don't pay nearly enough attention to not miss something. 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3. And then keyboard and mouse. Okay. Whew. Okay. All right. With that said, we need to store what kind of input method we're using. So var input method, methods. Okay, so this is going to be a dictionary. Keyboard. This is actually the same thing I was doing for Arteg Rise. Same sort of concept. Okay, and then we have controller 1. Actually, I'm going to fill up the keyboard first, and I'm going to duplicate it for all the other ones. So move left. Move right. Move up. Move down. Okay, so for the case of keyboard, this would be keyboard move left. Okay, keyboard move left, keyboard move right. You know, maybe this is an overkill. I don't have to repeat the exact same system I did in Arteg Rise. I could try to build up on it, because all we have to do is swap out everything before move left, right, up, and down. So yeah, I think that's way easier. So let's do this. Input method is going to be set to keyboard. Okay, just a string. And then func physics process. We're going to do if input is action just pressed. So we're going to do input method plus move right. I think there has to be an underscore. Yes. So if we do move right, then we need to set velocity.x equals let's do 300. Okay, now we need to move and slide also, so move and slide. Hey, nice. Alright, we're out of here. Let's skedaddle. Cool, a little fast. But that's the idea. Okay. Elif. Move left. Velocity x equals minus 200. And then right away, we'll do else. Velocity x equals 0. Nice. Oh. I used just pressed instead of pressed. Rookie mistake. Pub closed door off when it's time to pay for the bill. Alright, cool. Now, of course, not every one of them is going to be controlled by the same device. So let's do var character input. Okay, so first player is going to be keyboard. Second player, controller 1. Controller 2. And then controller 3. And then, once again, in the main menu, once we build that, we'll give the players a UI for selecting which character they're playing as and which control input they're using without repeating. So in this case, instead of input method, we could implement it, but let's say chosen input method is going to be an empty string, and then in the ready function, we'll just inherit it. Master node. What is it called? Character inputs. Player input. Okay, so player input methods, and then we'll just use the index of the player, which has to be calculated first, in order to choose which input method we're going to be working with. Okay, so chosen input method, and yes. Okay, so beautiful, I love it. The controller works, but not the keyboard, and it's giving me errors. Keyboard move left doesn't exist. Keyboard. God damn it, I always misspell keyboard with keyboard. I don't know about you, Bill. It's all the damn keyboards moving into town. What the shit? Wait. Key... Oh. It's, right. I didn't misspell it in the, settings. Nice. There we go. Alright. I don't know, damn keyboards mingling with my daughters. All 12 of them. Maybe Betsy. Okay. If input is action pressed. Okay. We're gonna do the same thing. Move up. Why don't I just copy the whole thing? Jeez. Move down. So this is going to be on the y-axis. Y-axis, y-axis. And I think we got to swap them. Nice. Okay. That works. It's a little fast, though. Why don't we do this? Let's add 20 times delta. So we'll have a little bit of physics. Let's do subtract. And then And then I suppose if we're not holding any of the keys, we're going to tell velocity on the x-axis to multiply equals 0.95. So subtract 20 times delta, add 20 times delta. We will have to put caps on it. All aboard? Okay, so 20. Set it to acceleration. Okay, that's a little slow. Okay. It's definitely there. The controller doesn't really take advantage of the strength. It's just on or off. Also, maybe what we should do is when we're trying to move in the opposite direction, the speed should be a little bit faster. We could try something like this. So var input vector input get vector. Okay, negative x. So we'll do this. Positive x. Oh, that's the other way around, actually. Okay, and then this is negative y. Okay, negative y is up. And then positive y. And then that's it. Yeah. Okay, now I could technically just use this to modify the velocity, but well, let's just ignore that for the time being. Var x speed. Let's do var x slowdown equals, let's say it's gonna be, our acceleration is 360, so when we go to the right and then suddenly switch to the left, we're trying to fight 360 times delta. So let's do 400. It's going to be 400 if the vector on the x, specifically the sign on the x, does not match the sign of velocity on the x. So we got to be, if we're moving to the right, but we're pressing to the left, this is going to be 400. Otherwise, it's going to be 0. And this has to be non-zero. So if this is not equals to 0, and it doesn't match, so we're moving in the opposite direction where we're pressing, this is going to be 400. Okay. Why are you complaining? Input vector x. Oh, well, hold on a second. What the shit did I just do? The sign function tells if the value is positive. Oh, sing. Jesus. If it's positive, negative. Returns same value variant as x with -0 for negative values, 1 for positive values, 0 for zeros. There you go. So we could just check if this is the same number as this one, or if it's positive and the other value is positive as well. These two is what I should be selecting. Okay, so let's try this. We're gonna try adding this up here, and this only on the x-axis. Okay, so as you can see, when it tries to like overpower it and slow down and change direction, it's actually a little bit more powerful. But if I do, let's say, up and down, it takes just as much to slow down as it is to speed up. But if I do left and right, stopping and changing directions is a little bit faster. Still got a bit of inertia in it, but that's kind of the whole point. Cool. All right, so we'll just do the same thing here. So var x, so there's a y slowdown, y-axis, y-axis, velocity y, and then we'll just do that again. Cool. And then this stays the same. Maybe I'll tone that down to 0.9. Okay, I could up this, maybe 600. Yeah, there we go. Still a little fast, but that's not a problem with acceleration. So this is max speed. What is it? 500 maybe? We did zoom in quite a bit, so we'll have to do velocity equals clamp velocity between vector 2, negative this and this. I don't know if clamp works with vectors. Vector 2, positive, positive. Hey, wow. Okay, cool. Apparently it does. Yeah, variant. Okay, cool. So that works. Okay. I have no idea if that actually worked. Let's set it to 300. What the? Okay, maybe it doesn't work. It should be negative, negative, and positive, positive. Well, at least what? What the shit? Okay, you know what? Just do that. Yeah, that works. Let's, just for the sake of a test, add a label, a label, speed. Actually, let's do a VBox container and then put a label into it. Data. Center. Noise. It's a little large, but okay. Sure. Cool. Can we make a string out of a vector? Nope. Okay. Yeah, okay. So that seems to be about right. It's really fast though. So 300's a bit much. Okay. Still too fast. We do have dash. Oh yeah, you know what? Horizontal or diagonal movement ends up being a little bit faster because of the X and Y stacking together. But I think I'll just keep that. It'll be a little way to juice the game. Snapped F to display floats. I see. Okay, let's get these guys actually running. So we'll do... We have the input vector, and I'd like to expose that so that it's available in other places. So we're going to collect it in the input function, but use it in the process function. Okay. So if input vector is not vector2 0, then animation player will play run. Else idle. Just limits. Oh, that's what it is. Limits the decimals for easier legibility. That makes sense. Okay, so this works. Speed-wise, however, not so great. Speed scale. We could just adjust speed scale. I didn't really plan on doing any slow-mo effects, but if I use speed scale right now, it means that no slow-mo effect for me. If I ever decide to do that. So let's just do the 12. Oh yeah, idle animation is going to be playing at 12 frames per second. It has all of 1 frame, but don't mind that. Run. I gotta tell you fellas, I can't wait to own a plot of land. Can't wait to move out. Hey. Okay. It works. It's a little fast. Yeah, okay, that works. We need to flip something, which by the way should probably be done here as well, as long as it's not 0. We are going to do flip h equals what? Flip h equals whether or not we are to the left. I think that's it. Yeah, nice. Okay, and then what was that thing you said about limiting floats? Snapped float x. Oh, but it doesn't take a vector 2 now, does it? So I'd have to do x and then 2 decimal points, is it? I'm pretty sure we can just do this. Okay. That just gives me a whole number. And that just gives me a whole number still. What the shit does this function do? Returns the multiple of step that is closest to x. Oh, this does exactly not what I thought it was doing. This can be used to round floating point numbers to an arbitrary number of decimals. Well, maybe it does. Oh, I have to type it in exactly as I want it to appear. Huh? Okay, 0.01. 0.01. Or not. No, it's there. It's doing it. Oh, okay. That seems to work. Nice. Okay, now, there is supposed to be a tiny bit of a shadow underneath the characters. We'll just snap something together. Where's my pen? Yes. Okay, can I remember which shortcuts are used in which software? Sprite. Oh, really? Wrong order. Nice. Alrighty. Now we do need the Z ordering to be enabled. So let's do a node 2D. We're gonna place players. I'm gonna call this content. And then we're gonna tell this node to organize as Y sorts. There we go. Nice. Okay. So that seems to work. What's next? Next, we need to do something about aiming. Okay. Now, I know that we have some things that we've put together. Weapon icons, and then there's also held weapons. Okay. So we got a few things. Sword, high-end, shotgun, pistol. Uzi. Okay. Now, when you start the game, you actually have a melee attack, which is just your punch. It used to be a separate selectable weapon. So if you had 5 pistols, 10 shotguns, you had to scroll all the way up to select your weapon as a hand. I think this time around we're gonna probably not do that. We're gonna probably not do that. We're gonna do melee as just like a regular melee thing. Oh man. If we do regular melee as a separate button, yeah, in that case we don't really need the hand. We only need the hand up until the point where we don't have a weapon anymore. Also, this hand is looking totally different from the other hands. That seems a little weird. Okay, are these characters your friends in real life? Well, one of them was. The other ones are just fillers. So we can't have people playing as the same exact character. I've done enough of that. Okay, so I do need to center the pivot points. Probably like this. There we go. And then the sword is... yeah, there we go. Okay, we can export these. Let's do tools, scripts, export layers. Weapons held. We're going to export all... yeah, they're all going to maintain the same dimensions. Ignore invisible layers. And... yeah. Okay, that's good. Witch of Endor. Assets, engine, sprites, held, weapons. Export it out. Is it done? Yeah, nice. Okay. So, the weapons are going to be pivoting, so we're going to do a node 2D first, and then we're going to do a sprite. Okay. Held weapon. Let's start by just randomly assigning one of the weapons. Held weapon. Oh, wait, what? Why did you export the white background? Oh, these are JPEGs. I am JPEGs again. I did not select the export property. Export layers. Pung. Once again, do this. Yep. Engine, sprite. Weapons. Weapon. Wait, what? Oh, right. It creates a folder with the name of the project. They should really put an option to not do that. Yeah, I've always found the Uzi to be such an awesome, compact little weapon. From the Matrix movies down to what is it? Ghost in the Shell. Man, the Uzis are always super nice. Okay, so I'm gonna take these. Actually, no. I'm gonna put them like that. Let's do pistol. If anybody hasn't watched Ghost in the Shell, the animated movies, seriously, watch them. They are flippin' awesome. Okay, this is looking good. weapon pivot. Okay. Now, why don't we do a separate function called... maybe this one can stay. Again, I don't expect to have too much code here, relatively speaking, so I guess we just do this. Weapon pivots. Maybe for shooting I should give it a separate code, separate function. So weapon process, no underscore. We'll forward delta in here, and then in the process function we're gonna call weapon process. Forward the delta, and that's it. Okay, so this weapon pivot, rotation degrees, I guess we just work with rotation since we've learned how to work with radians a little bit better. We need to calculate the direction from the player, so global position, not direction to, it's angle to point. Okay, does anybody know the difference between angle to and angle to point? I, for the life of me, could not figure out what the hell the difference is. Angle to returns the angle to the given vector in radians. Angle to point returns the angle between the line connecting 2 points in space. Well, returns angle to the given vector in radians, but it still expects us to provide a starting vector 2 and then in the beginning, and then dot angle to vector 2. So it's like, what is it, a global position to a particular vector? That makes absolutely no bloody sense. I'm misunderstanding it. So, yeah, anybody. To what? Get global mouse position. Okay. Now, all of them are going to do a little bit of this, you know, synchronized backstroke. So everybody needs to do the calculation relative to their controller. Okay, so if chosen input method is keyboard, then we do this. Else, the weapon rotation is going to be based on the angle of the joystick. So input get axis, negative action, positive action. No. Get joy axis. Okay, the device ID would be determined by this number. So if we take this, cut out controller under, and then subtract 1, or maybe I just don't make my life so difficult, now just do this. Should have done this from the get-go, but whatever. Man, I hope my local theater plays the Batman and Robin, because we actually had a lot of fun watching the original Batman movie. The original, whatever. What killed the dinosaurs? The Ice Age. Okay, so we need to get the controller ID. So we can take whatever chosen input method we have, we can replace controller underscore with nothing, and then we can turn the whole thing into an integer. I think we can do this. And then the axis Get joy axis. But that gives us a float. Do we not have one that gives us a vector 2? Get joy vibration strength. Nope. We get to be the basic bitches. So... okay. So this would be right axis X. I could write it as one line, but just visually makes me want to puke. So let's do joy X, and then we're gonna do joy Y. There we go. And then vector 2, joy X, joy Y. And then we can extrapolate the angle from it, and that becomes the rotation. Hey! Okay. Now the only thing right now is it's not quite pointing in the right direction. I'm pushing the controller to the left, or to the right, and then it's looking to the left. So, we're gonna do add pi. Nice. Okay. That's good. And then for the other one, I think pi as well. Yeah, there we go. So now it's pointing in the right direction. Come to think of it, maybe the direction of the character should be based on where they're pointing. So in that case, yeah, that makes more sense. So let's do this. If it's keyboard, then the flip will be determined if global position on the x-axis of the player happens to be larger than the get global mouse position on the x-axis of the mouse. Almost. If it's smaller then. There we go. Okay. Now, we also need to flip the gun upside down, so we're going to take the weapon, flip V, or flip H. When the gun's upside down, yeah, flip V. And that is going to be also based on this condition. Oh, can we stop destroying the code, please? Nice. There we go. Okay, you know, the animation doesn't look too bad. I think I just had to match the bounce. Even though we do have a bit of a leg shuffle happening there. Okay, same thing with this. Except instead of mouse position, we can use the joy X. But that's not even the full condition. The joystick isn't relative to the player. So I guess this would be if it's less than 0. If it's larger than 0. And same condition here. Nice. Look at that. Okay. Now, it would be nice if the gun was also bobbing up and down, which we know that the animation, the run cycle, has 6 frames in total. So that's 2 bounces. Left leg, right leg. Okay. So I could hypothetically do something like this. We have weapon pivot. What's the position of that? 1, -13. So let's do this. Position on the y-axis equals -13 plus, we're gonna take the frame and we're gonna add it to the position. Okay, so you can see it's just going down, but it's only going down once per full cycle. So I'm going to modulus it by 3. So every third frame, there we go. You can see every third frame, it does like a little bounce up and down. Now, I do want to maybe make it a bit off. So you can see how it's doing this. Every step, it's actually going the opposite direction, which kind of, at least to me, kind of makes it look like it's got buoyancy to it, or it's got weight to it, and you know, as you're going up, the gun is so heavy that it takes a little while for it to go up as well. So little tiny piece like that. Nice. Okay, not too bad. Well, what should we do next? We need to do the break because it's been an hour. So let's take a short one. I think we'll have maybe 30 minutes to do something else, because I do have some commitments that I have to take care of at, what? At 7. Cool. So let's take a short break. Alright, there we go. We're recording. Yes, we are. Perfect. Cool. Okay, so let's do a quick effect to start with. This is going to be a little puff of something. A little puff of dust. Can I get the dimensions of this guy? 64, so it's probably 32. Okay. Okay, let's do 32 by 32. There we go. No recording reminder needed. I managed to remember to do it. Okay. This is going to be a puff of smoke. Okay. We're going to see how this works as the dust that you kick up as you're running through the land. Okay. Now this animation has to be exported as a sprite sheet in order for it to be usable in a particle. Actually, I do need to save it, so this is going to go to assets, walk. Oh, we have a walk particle of some kind, but let's just use this one. Let's go to tools, export a sprite sheet. That's a plugin that you can download off of GitHub. Let's do Witch of Endor engine sprites. This is going to be called walk dust. All right, beautiful. Particle. I guess we're doing GPU particles. No subemitter. We need a particle process material. And the texture, walk dust. We're going to make it nearest neighbor, so it's the pixels are nice and crispy. And then material is going to be assigned a canvas. Canvas material. It has a particle animation, and it has how many frames? 3 by 3 by the looks of it. Hey, there we go. 3 by 3. Ah, yes, combat pissing. Yes. Tactical urination. Okay, let's go to display, animation. Whoa, what is this? Oh, these are some new sliders. What is like a range slider? Damn. Okay, well, minimum and maximum have to be 1. Cool. No gravity. He's asserting his ownership. Displaying his dominance. Okay, cool. We do need to maybe set the color. Okay. Walk dust. And we're going to make it not emit unless we are walking. So the emitting is going to be true if this condition is true. Mm-hmm. Okay. Now that technically works, but it's not working too great. Oh boy. What are we racing? Also, the should probably be over here. Okay. I'm not exactly a fan of that. Let's try something else. Okay, let's try this. The shit. I think part of the reason is that it's too slow on the app start. Oh, that's looking a little bit better. That actually looks more like a particle you would see when a bullet hits the ground. It's not too bad. Maybe we're gonna start with this frame. Oh, okay, that's a different number of frames then. 4. Nope. Yeah. 3x2. The alignment is also off. No, that could work. Maybe if it's not so bright. Oh, we didn't do it here. We did it in the draw display. Yeah, okay. That could potentially work. What did I have for the actual dust? Walk dust. There was a walk particle. Oh. What the? Oh, it was like 3 frames. Did you do it? Convert to... Oh, it's got to be a group. Right. There we go. I think that's pretty much all it was. Okay, that is confusing as squat. Hold on a sec. I think it's... Ah, it's just 2 by 2 now. Okay. Yeah, there we go. That's the original dust. Okay. It's very simple, but it does work. Okay. All I have to do is maybe give it a bit of randomness. Mm-hmm. Okay. Maybe even a little bit of rotation. Okay. Radial velocity. Not what we want. Emitting only when his theoretical feet touch the ground would make it better. I know what you're talking about. I remember the effect looking distinctly like this, where it's more like a dust trail. And if I make it only be displayed when the feet touch the ground, I think there's just going to be too few of them. Too few of these particles. But yeah, you are correct. I like this. This works. Like a little, nice little dust trail. And this was the needed effect. The particle had to already be pretty big when we step. As far as I know, these particle emitters don't actually have a method. Emit particle. Okay. Velocity color, custom color, flags. I mean, technically this could be potentially it. Returns a rectangle containing the positions of all... Wait, that's not it. Hold on a sec. Emits a single particle. Ah, okay, so it wouldn't be like a burst. I'd have to instance these dust particles. Actually, hold on a second. Can we not make it, like, rise up? Should we? I don't know. This looks pretty good to me, to be honest. Also, yes, the black guy has a white arm. The amount of extra work that I have to put into making a separate sprite or a shader that colors the hand brown is too much, so I guess we're going to be participating in a little bit of whitewashing in this game. Sue me. Alright, because bouncing afro should compensate for it. Or we'll just assume that he's holding the gun with the inside of his palm. Or with the outside of his palm. Okay. Cool. I gotta say, this is actually starting to match the aesthetic. Not bad. By feel and visual design, so that's good. Let's get something to shoot. So, let's get a character or something that shoots. So this is bullet. Sprite. Okay. Oh yeah, we also had footsteps, so we could make the characters leave. Bullet. Do we not have a bullet? I guess we don't have a bullet. Alright. Whoops. 16 by 16. Which might actually still be too big. What the? Yeah, that could work. Ditch the black dude and prepare for the consequences. No, man, we gotta have the diversity. Yeah, that's what we want. Gotta put those check marks. Bullet. But my initial choice of characters was I just wanted a black guy with a fucked up afro. Which of Endor engine sprites bullet? Okay. So let's give this. There's the bullet. Oh yeah, we gotta save this. Scripts, bullet. Ah, come on. All the crap. Move and slide. We're just gonna call it here. And we're not gonna do anything else in the bullet for the time being. Instead, we're gonna go to the player. Weapon process. This is where we can handle our shooting. So if input is action just pressed, and now we need to have the actions for shooting. So controller 1 shoot. Oh yeah, one of the staples of this game is that you have to manually reload your gun. Which is just, like, when it runs out, you have to press the reload button. Okay, so mouse, left click. Regular trigger for these ones. Yes, 0, 1, 2, 3. It's looking good. Is action pressed? Okay, so chosen input method plus underscore shoot. This is where we do the shooting. So to do the shooting, we have to preload bullet. Yup. Set the texture filter for project. That would be a smart idea. Nice. Good call. So, new bullet variable will contain instantiated copy of the preloaded bullet. Next, we need to position it at the tip of the weapon, which that would usually be something different for depending on which weapon we're working with. Let's do node 2D. I'm just going to position it right there. Bullet point. Sure. So first we'll get parent, child, the new bullet. Next, new bullet global. Okay, we know that it's a character body. So global position is going to be the bullet point global position. Okay, and we also need to tell it how fast and where to go. So we're going to set the velocity to be what? I guess we could take this, get the rotation. How do you get velocity? Can you get direction from angle? You know what? We could potentially use one of these values. I'm going to declare that as a global so that it can maintain its value, bullet direction, and then here the bullet direction is equals to, could use player position minus hand position normalized, but player position is at the foot and then the hand position is, you know, wherever the hand position is, so it's not quite pointing in the right direction. I could, however, I could, however, do this. So we have bullet point, and then we have this. This gives us a clear trajectory. And I think I have to do this because different guns have sprite pixels that are in different locations, so the barrels will be in different locations. So this seems like the easiest way to do it. Bullet direction tip, bullet direction base. Okay. So in that case, we don't need any of this stuff. And then we're simply going to do base, global position, direction 2, tip, global position. And then times whatever, 700. Beautiful. We don't have this node anymore. We have a base now. Nice. The position is off. Why is that? Oh, when we flip the... Damn it! When we flip the gun, the axis won't actually line up. So here it looks good. As well, actually... If you're playing with a mouse, I think you'd be expected that your bullets would fly towards the mouse. So... Well, wait a minute. We do know how to get direction from angle. That's exactly what sine and cosine is for. Now, I know I could stick to this system, but I kind of want to experiment with that. Yeah, let's do that. So... This means we should be able to use a weapon pivot for both of them. Okay. New bullet. Dot velocity. It's going to be vector 2. Cosine. Rotation. And then sine. Rotation. If I was smart, I would actually talk to these nodes properly. Okay. Now it's going the opposite direction, which we knew was going to happen. Yeah, there we go. Okay. And we need to add plus pi plus pi, because we kind of drew all the weapons looking to the left. Okay, that doesn't actually resolve the issue with the flipped gun. We can technically resolve the issue with a flipped gun if we make sure that all guns' barrels are centered. Except for this. This is a sword. Or this. That's a finger. So we do this. Center barrel. Center barrel. Center barrel. PNG, ignore invisible. We're exporting weapons held. Okay. Interesting. Okay, there we go. That seems to work. It still doesn't shoot where the mouse is pointing at. So I think I know why. Here, when we rotate it, we don't rotate it from global position. We don't calculate the angle from global position of the player. We do so from global position of the weapon pivot. There we go. Nice. Okay. That seems to work. I'll just move this out a little bit further. And then it's moving a little bit too fast. The whole idea is that there are tombstones all over the map where you can upgrade the stats of your weapon. So the weapons are really supposed to be kind of slow to start with. Cool. Well, there we go. We have our starting point. Hey man, I feel outnumbered here. Okay, cool. Alright. So that's it. 7 o'clock. I gotta bounce. Am I gonna have enough time? In 2 hours, if I'm not 2 out of it, it's gonna be 9. Maybe I could fit another hour. Or... Nah, you know what? Let's save it for tomorrow. Tomorrow's Sunday. Sunday, bright and early morning. I'll hopefully, I'll see if I can get up bright and early and get some additional work done on this. But not bad. It's pretty good leeway, and I do feel like the game is being rebuilt in the accurate representation of what the game used to be. Cool. All right, fellas. Have a good rest of your day. We'll see you tomorrow.